Okay. Huh. Might have picked the wrong shirt for this microphone. But let's see what we can do. Alright. Wait until that falls off. So, we are back after 2 weeks, taking a small break to see the direction and organize a few things. Still not done. But, if you were here for the last series of videos, we started off doing design patterns and then applied them to our own text-based adventure game. And that game was called Mudsy. So I've kind of broken this up into this idea of semesters. If you're new, then I'm doing this as a way to kind of polish up my teaching skills and maybe one day transition to a career of community college education. So first semester, kind of a work in progress, but we did 6 design patterns, and then we did a review session where we didn't do any katas for the adapter and the interpreter pattern, but they are in the code, and with the idea being we did 6 patterns, one from each group of creational, behavioral, and structural. And once you kind of have those core mechanics of what a design pattern is, you can really dissect any of the other ones you come across. So we kind of experimented with that with these two. Can we just look at it? Do we need to do a kata? It's really just the same ideas represented in different ways. I think we're good. So in the second semester, I thought we'd just hit the ground running. So no more katas. We're going to jump right into the examples and see how far we can get without having to double back and start from scratch. Does that make sense? I hope so. So let's look at our Mudsy game first and where we left off. Okay, so we left off with this playable game where we have a world and so far just one room, a bunch of test stuff that we can look at, we can use, and we can look, we can fight, really anyone we want. We can look around again, we can look at Beth, we can fight Beth. So we just killed Beth because she only had 6 health, but we didn't get like a message about it. So there's still some places we can improve, but she's no longer in the room because she's dead. Carl has 92 hit points, so now I'm thinking maybe it was a mistake to kill Beth because every time I attack, I use up 2 stamina, and I'm not going to be able to kill Carl, who was a zombie, with the stamina I have left. Alright. And we started adding some things like get things off the ground, air handling for that kind of stuff. So, pretty good. So what does that have to do with the Singleton? Well, right now we just have a console app. You can't really do much with a console app as far as a multi-user dungeon. We have to connect it to something. We have to have a server. So I thought that'd be cool to write that from scratch as well and figure out how this whole thing starts to get a little bigger, right? And let's take a quick look at what we'll be using for that. So I wrote this pretty simple, easy TCP server and client. And I took it from this example on MSDN. And I made some modifications because this one, for as good as it is, it's not quite as robust as we need. And sockets really are the way to be programming these days. Kind of don't get locked into this idea that everything has to be a web app, because that thought is, or that way of thinking is kind of on the way out. So, took this example. I'm going to go ahead and close MudZ for a second. And created this project where we've got common, client, and server. So let's just assume that this part of our project was written by somebody else, and now it's our job to either mess around with it a little bit or consume it. So this is really the way it would happen if you were on a team. Somebody else would have said, okay, hey, I'm done with the server, use it as you like, and they disappear. So we're inside the server, and all we're doing is creating a new listener, and we're starting to listen on this IP address and this port. So if I start that guy up, it's going to say waiting for connection. So I've already built the client. I can't debug two things at once. So let's go into the client's bin directory. Let's find the executable. Let's go ahead and open it up. Alright, so all I get here for the client is a prompt. If I come back over to this, it'll say, hey, got a new connection from this port. Okay, so far so good. So the server knows I'm here. So what happens when I type something? Test, enter. Alright, so the server gets the request and then sends a very generic response. And then I'm free to type something else. Cool. Okay, so let's open up a new client, and it says it's got another connection, this time from port 68. Boom, let's open the third one. New connection. Okay, so alright, so whoever this person was that wrote this project, he or she did a pretty good job, and we have the basic elements of a server. So without getting too much into the TCP world, essentially what happens is the server starts up, and every time a socket comes in, it sets it off to an asynchronous listener. So it's not exactly multi-threaded, like in the way of we're not actually starting up a new thread. We're using the async and await pattern, which has some stark differences between normal multi-threaded operations, but essentially we're creating this non-blocking application that can keep receiving connections, and those connections are handled independently of the main application. So that leads us back over to our MudZ game, where we now have the ability to set up a MudZ server that listens for connections. But what we don't want to have happen is we don't want to have multiple hive minds, right? So we want one game engine, one hive mind, one game master per server. And the way to ensure that is with the Singleton pattern. And the Singleton pattern is notoriously the pattern which is avoided. Nearly every time you go to use it, it's a hammer looking for a nail, and there's very rarely a good reason. There are good reasons, but there are great reasons actually. But in your day-to-day programming, if your first thought is Singleton, you should probably pause and say, is this really the problem I'm trying to solve? And in our case, it is. Because we want, if we go into our core, and into our model and our domain, and we've got our environment, our game engine, we've got our hive mind. So we only ever want, and I'll get rid of this unused using statement, we only ever want one of these to exist for our application domain. So we never want the two people on the same server to get answers from different hive minds. So we come back over here to a really good article called C# in Depth. There are multiple examples of how to do the singleton pattern. And this also makes it a very hard pattern to make a kata for. But this is a great write-up because it shows the simplicity of the singleton pattern and also shows a lot of the caveats and a lot of the reasons why you would want to do it one way over the other. So, and this is a great time to kind of talk about, I read this really good article about Asimov and like the nature of being wrong and how, wrong is really just less correct. So this first version, it definitely is a singleton, but it's not thread safe. And because we're going to be dealing with a server that could be operating on multiple threads, we definitely want thread safety. All right. The second version is what you're typically going to find not only in C# but also in Java in terms of how to make a singleton. We're going to create a lock. We're going to make the instance static. So this is going to be shared in the app domain. But if it's currently being in use, we want the caller to wait. And pretty much the same thing, but just doing double check locking. So we're not going to go into all of these because the one we want is actually the last version. Oh, I mean not the last one. Hang on. The fourth version. Okay. So what this does is it removes the need for locks, and instead it uses a static constructor. And they really are right when they say this is extremely simple. This is the easiest way to make something a singleton. And there are a bunch of caveats, which, we should definitely, read and pay attention to. Suffice it to say, none of them really apply to us. So we can use the simplest example and still get all the advantages of a singleton thanks to the .NET language. One of the caveats of doing it this way is it's really something you can only do in .NET, right? So using this double locking, this is going to be more portable to something like Java, and the concept is a little more approachable by people from other languages. But for our needs, I think this will be just fine. So we're going to use a static constructor. Okay, so go to the hive mind. And we'll make this static. And immediately you get a bunch of ness, right? And the reason why that is because these things are not static. That's rough, right? So let's go back in and see what we can do about that. Let's move this off. And we'll see not only how to fix this, but how maybe this isn't quite as simple as we had hoped. Okay. Pull the guy off. So now we do have our static hive mind, but we've lost the seed world and all this stuff. Not great. So what you need to do is back all of your properties with fields. So we're going to return the response stack, but if it's null, then we're going to return the result of this statement. Hope that makes sense. And then we're also going to allow this to be set. No, we're going to make it a private set. We don't want anything messing with our world.